So in this problem, which I'm using a different piece of paper than what you'll have in the handouts online, but we want to draw a Lewis dot structure and any resonance structure for these two ions. And so in this molecule, the first step is to sum up our valence electrons, which is going to be 6 for the sulfur plus 6 times 3 for the 3 different oxygens. And this -2 charge says that we need to add 2 more, which gives us 26. From here, we're going to put sulfur in the center, connect our 3 oxygens, each at 90 degrees because it's a Lewis dot structure, start plopping electrons around. So once we do this, we'll have used 24 electrons. So we can put the other 2 on sulfur. Whoops, that looks kind of terrible. But now we have used all 26 valence electrons. From here, the issue becomes we need to look at formal charge. So formal charge is equal to, so this will be for the oxygen. It will be the number of valence electrons, 6, minus half of the bonding electrons, which there are 2 of, minus all of the lone pair electrons, which is 6, which gives us a -1 charge. So in this structure, we have a minus on all of these. So then for sulfur, it's going to be also 6 minus half of our bonding electrons, which is 6. And then we can also subtract the lone pair, which gives us +1. Now, in this case, sulfur has the ability, so this is one structure. However, we might be able to reduce the formal charge if we were to create a double bond, because sulfur has the opportunity to expand its octet. So in this case, we could perhaps draw a structure that looks like this. So, oops, forgot my lone pairs. When we draw this structure, everybody has octet. Sulfur now has 10 electrons around it, but sulfur has the opportunity to do that. So we can calculate the formal charge. These 2 oxygens will still have negative charges. Sulfur, in this molecule, the formal charge for this will be 6 minus 2, 4, 6, 8, half of 8, whoops, minus 2. So in this case, sulfur is now neutral. This is a good sign. We can calculate the formal charge for this oxygen, which is 6 minus half of 4 minus 4. Now this is neutral. So this is going to be slightly preferred because it has the opportunity to reduce the formal charges. So from here, because we have a double bond and 3 equivalent atoms, we can create a resonance structure, which would look something like this. Where essentially our negative charges are going to change atoms. So what we've seen is our double bond has rotated, so we can see it on this oxygen at the end. And so, oops, forgot my formal charges. So there are 3 equivalent resonance structures. All 3 would be connected by these double barbed arrows. So our next ion is this ion. Now this is a chloride ion, so that's a ClO2. Don't forget, if you were to see this on the exam and you were uncertain whether it was this molecule or a carbon, always feel free to ask. In this case, chlorine is going to be our central atom, connected by 2 oxygens. We, however, forgot our first step, which is to sum up our valence electrons, which in this case is 7 plus 2 times 6 plus 1, which gives us 20. So we can follow the Lewis dot rules, which is to put all of our electrons around our exterior atoms. So we've now used 16 of our total 20. So we can put them all here. So in this molecule, again, our first step is to calculate our formal charges. So for chlorine, it is 7 minus half of 4 minus 4, which gives us plus 1. For our oxygens, the formal charge on our oxygens is going to be 6 minus half of 2 minus 6, which is negative 1. So similarly to our first question, having formal charges on all of these is slightly complicated. From here, we can actually make a resonance structure where we can, let's see if we can make a structure with a double bond between chlorine and oxygen. Again, that will increase the octet, but based on its location in the periodic table, chlorine can expand its octet. From here, we can draw this molecule. So we know that this is still a negative charge because it looks the same. From here, we can relook at chlorine to where it is 7 minus half of 6 minus 4, which is 0. It's a good sign. So now we only have one negative charge, and this one will be 6 minus half of 4 minus 4 is again 0. So we can make two resonance structures here. That are symmetric.